Welcome to the third video of Chapter 4. Today is Section 4.3, Proving Triangles Congruent by SSS. So before this, we wrote congruency statements, and we talked about how congruent figures have all sides and angles congruent. Now we're going to learn one specific way of proving triangles congruent. We're going to do a few proofs today, and then we're going to have an actual proof day after this. So two objectives. First, we're going to determine if triangles are congruent using the SSS postulate. So that's either yes, they're congruent, no, they're not. And then we are actually going to prove triangles congruent. So first thing we should probably talk about is what is SSS. SSS stands for side, side, side congruence postulate. So this postulate says two triangles are congruent if they have three pairs of corresponding sides that are congruent. So if we draw ourselves two triangles and label them A, B, C, D, E, F, these two triangles are congruent if all the sides are congruent. So AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. In this case, we would say triangle ABC is congruent to triangle DEF, which means all the sides are congruent and all the angles are congruent. So although we only have three sides, this tells us that the angles are congruent as well. Okay, so again, all this is saying is two triangles are congruent if we have three pairs of sides congruent. So let's look at examples 1 through 3. It says decide whether the congruent statement is true, and then explain your reasoning. So looking at example 1, I have two triangles where three pairs of sides are congruent. So yes, these triangles are congruent by SSS, that's true. But we need to make sure that the congruency statement is true. So we go D, F, G, and H, J, K. So DF is congruent to HJ, okay? DF is congruent to HJ. Yeah, that's true. FG is congruent to JK. FG is congruent to JK. Yeah, that's true. And then DG and HK are also true, or also congruent. So we would say yes, these are congruent by SSS. Looking at example 2, I have two triangles. I have triangle ABC, triangle ADC. Okay, first thing, do they have three pairs of sides congruent? Well, I have 7 and 7, 9, which is congruent to itself, and then the third pair of sides are 3 and 4. Those are not congruent, so I don't even need to check the congruency statement. I can right away say, no, they are not congruent. Right now, I would like you to pause the video and do example 3 on your own. Decide if the triangles are congruent, and if they are, check the congruency statement, please. Okay, so first thing, you should have determined that yes, these triangles are congruent. We do have three pairs of sides congruent. Now I need to check the congruency statement. Is QP congruent to RS? Okay, QP and RS. Yes, that's true. Is PT congruent to ST? PT, ST. Yep, and then last one is QT congruent to RT? QT, RT. Yes, so we would say yes, these triangles are congruent by SSS. I will tell you, sometimes you're going to run into triangles that are congruent but have the wrong congruency statement. So make sure you keep an eye out on that. So looking at example 4, triangle JKL has those vertices and triangle RST has those vertices. Graph the triangles and show that they are congruent. Okay, so I'm going to start with triangle JKL. J is -3, -2, so that's here. K is 0, -2, so that's here. And L is -3, -8, so -3. So this is one triangle. I'm going to move that J so we can see it better. Now let's do RST. RST has 10, 0, 10, -3, so this is R, this is S, and then 4, 0. Okay, so first thing I need to start by finding the sides. Any of the sides that are vertical or horizontal, I can just count. So JK, for example, is 3 units. I could just count. There are 3 boxes. JL is 1, 2, 3, 4, 5, 6. I can just count. Now for LK, I actually have to do the distance formula, and that's because it's on a slant, it's on an angle. Okay, so remember for the distance formula, I have to subtract my x's. So I have LK. So I have 0 subtract -3 squared, and then subtract my y's. -2 subtract -8 squared. So I get 3 squared add 6 squared, which makes sense if we look at our triangle. We have sides of 3 and 6. So this is the square root of 9 add 36, which is the square root of 45. If we break that down, 45 is 9 and 5, 9 is 3 and 3. I have a pair, so that becomes 3 root 5. So 3 root 5. Right now, I would like you to pause the video and find the blue triangle, triangle RST. I want you to find all 3 sides. When you are finished, come back. Okay, so you should have started by counting the horizontal and vertical sides. You should have gotten RS to be 3 again, and TR to be 6 again. And then when you do TS, you get 4 subtract 10 squared, and 0 subtract -3 squared. When you simplify, that ends up being root 45, which we already know is 3 root 5. Okay, so then I'm just going to have us write one last sentence. So triangle JKL in this case is congruent to triangle RST. JKL. So let's make sure that that's the correct congruency statement. JKL is side 3 root 5, and then 6. So I need to do that again. R is 3 root 5, 6. So that's the correct congruency statement. So the triangles are congruent by SSS. And that's it. SSS. They have 3 pairs of sides congruent, which we just showed. So hopefully you got that one right. If not, please bring any questions that you have to class. Right now, if you would please flip to page 14. Okay, last example that we are going to do is we are going to do a proof. Okay, so first thing that we always do before we even do anything else is write the givens. So we have 2 givens. We have KL is congruent to NL. That's given. Okay, let's mark that in the figure. KL and LN. That was already marked. Then I have KM is congruent to NM. Again, given. Okay, here and here. Now, I want to prove the triangle's congruent. At this point in time, we only know one way to prove triangles congruent, and that's that they have all 3 pairs of sides congruent. Well, right now, I have 1 pair of sides here. I have another pair of sides here. So now I just need to prove the 3rd pair of sides are congruent. In this case, the 3rd side would be LM, and that's the 3rd side for both triangles. So I would say LM is congruent to LM. That's my 3rd S. Now, what property says that any object is congruent to itself? That's the reflexive property. Okay, now I have SSS, so I'm ready to say that triangle KLM is congruent to triangle NLM. And then the reason is SSS. 3 pairs of sides congruent. Okay, so we're going to have a few of those in the classwork that we do, but then we are also going to have a proof day where we do all types of proofs involving SSS. So if you have any questions, please make sure you bring them to class. If not, I will see you tomorrow.